Welcome. Welcome to a new problem solving session. And here is the problem at your screen, if you can see it clearly. One of Jaan Kalda's problem, And I think this problem belongs to Jaan Kalda. It must have been something. हालांकि एक बात जो सीक्रेट में बोलनी है क्योंकि वो बाकी के लोग इंग्लिश समझते हैं। ये काल्डा का प्रॉब्लम है, किसी ने थोड़ी देर पहले भेजा मुझे कि सॉल्व इट। तो इसका सॉल्यूशन है अवेलेबल, बट कुछ बच्चों ने किया है, शायद बच्चे बड़े हो जाएंगे। अभी क्या है कि ये प्रॉब्लम देखते हैं। दिस इज मिस्टर कल्डा हिमसेल्फ, and this is kind of problem. A heavy bags is being pulled using two tractors. One of these have velocity v1, this one I think, and the angle between and other v2, sorry, this tractor's velocity is v2. The angle between velocities is alpha. Oh, it is alpha. And what is the velocity of the box, this box? If it assumes that ropes are parallel to velocity vectors, that must be, I know, that means rope are taut, nothing else. Oh, I think, what can be the problem? So, let me solve it using very basics, and I just clear the picture. I have something like I got an object here like this, and this is being pulled by two ropes with velocity v1 and v2, and angle between them is alpha. So what velocity should be imparted to this block? इस ब्लॉक की क्या वेलोसिटी होगी? I think जो भी होगी, I'm not very much interested in solving this problem, लेकिन इस ब्लॉक की जो भी वेलोसिटी होगी कुछ होगी, like this कुछ होगी वेलोसिटी, मान लिया उस वेलोसिटी को भी, then it has already provided two velocity vectors, in fact, by some rope or by some cord, and this angle is alpha. That's true. If I take this angle as beta, this angle is going to be alpha minus beta. If you can recognize this, and the velocity components of v along this line v1 will be something like this. This will be the component, and in the similar manner these are two components of velocity v on v1 along the v1 vector and v2 vector. Of course, these two components are certainly, these two components doesn't make a rectangle. So this vector and this vector, because these are not even v1 vectors as a whole, these are components of velocity vector v, and this can be simply written as v1 cos beta. As you can see, here is the angle beta, and this component will be written as v cos alpha minus beta. And so I guess according to the problem, this V1 cos beta should be equal to V1, and what is this not V1 cos beta, it should be V cos beta. V cos beta should be V1 and V cos alpha minus beta, this should be V2. This is a simple thing, and alpha is not equal to 90 degree, that means this B1 cos beta is equal to B1 and B2 cos alpha minus beta is B2. So I can do one thing. I would like to find B1 minus B2, B1 divided by B2, so that B1 becomes B cos beta. So you can write it here, cos beta by cos alpha minus beta. It's simple manipulation. And then you should do one thing, that B1 upon B2 become cos beta divided by cos alpha cos beta plus sin alpha sin beta, and I can do one more thing, so that B1 upon B2 can be written as 1 upon, I divided both numerator and denominator by cos beta, so that the numerator is only 1, and this can be cos alpha plus sin alpha tan beta. And you have to get tan beta from here, because everything else is known. Alpha is known, B1 is known, B1 is given, B2 is given, alpha is given. You have to find out only this tan beta, that means beta, and then you will get V from here. So I'm going to get it. Problem is solved, at least problem is solved from my point of view, because I need what? Tan beta. I can write simply as tan beta, sorry, not tan beta. Why should I try this thing? I should go step by step. I should write cos alpha plus sin alpha tan beta equals V2 upon V1. Then I can write sin alpha tan beta equals V2 by V1 minus cos alpha. After all, I have been a CBSE student, so whether I learn something or not, I must have learned a step by step thing, and that means tan beta we get is 1 upon sin alpha B2 by B1 minus cos alpha. And if you wish, you can write something like that. One more step. V2 upon B1 sin alpha minus cot alpha. This is your tan beta. From my point of view, problem is solved, because we earlier had something like V2 cos beta equals V1. That means V equals V1 upon cos beta. So V equals V1 upon cos beta. That means this is V1 sec beta. So the answer will be V1 under root 1 plus tan square beta. And I think you got the answer. Somebody told me that Jaan Kalda's answer is not this. Put the value of tan beta. I know Jaan Kalda. The problem must be on basics. Somebody gave you a different kind of touch, and I thought Jaan Kalda put a bigger challenge for you. This is not the case. Thank you for watching.